Slide 2.
Okay.
Okay. I assume all of you has probably used Snap one time in your life, right?
Oh yeah.
Yeah.
Okay. True? Okay. Anyhow, Snap's shorthand for System Neutral Access Protocol. What that means is that basically Snap is intended to be multi-platform and multiple device and all that sort of stuff. It's got what we call platform-independent device driver architecture, which essentially means you write the device drivers and don't worry about whether they're going to run on Linux, OS2, or whatever. Now, obviously, there are platform-dependent versions, but we'll get into that a little later, a little bit. And there's implementations, OS2, DOS, Windows, Linux, and others. Anything? Any questions?
Nope. Not so far.
Nope. Next slide. A little bit about Snap's history. If you want more details, Wikipedia has a fairly good article on it, as well as some of the related things, products that ended up being sort of merged into Snap. But anyhow, it was developed by Kendall Bennett, SciTech. He had earlier video driver products that were supposed to be basically universal bus plus accelerated drivers, and this all merged into Snap over time. As I mentioned before, it's been ported to numerous platforms. One of their businesses was actually selling to folks that were doing embedded systems. So Snap is probably existing on some point-of-sale system that we've seen that. Initially, Snap was supported only video drivers and video chipsets. Somewhere along the way, they decided, well, we can do this for audio too. And they did, which is basically, they put in the APIs necessary to initialize and control audio drivers. And I believe there are some test case versions of audio drivers for OS2 in the code base. Eventually, SciTech sold their product line to Alt Richmond. And Alt Richmond has not really done any new development on it, but they have licensed the product out to several third parties. Arca Noae being one of them, and Ventus also is a licensee. Any questions?
No.
Okay. One thing that characterizes the source code is it's big. And it's not any different application that is very large, but they do support quite a large number of chipsets. And each of these has its own driver. Now, the bulk of the code is in the common code, but still, any of you who have looked at driver sources all know that there's always probably about a third of the code is hardware dependent. And when you've got, and I think that last time I looked, there was probably well over 100 sets. So the code itself, again, is large. It does a lot of things. Source code, combination of C, C++, and assembler, the usual stuff. Mostly C and assembler for the drivers, as expected. The C++ is typically found in the platform-dependent code. Any questions?
Steve, you were breaking up there. How many chipsets did you say were in there?
Pardon? Good. Okay. Where did I restart? I'm not sure you made a connection problem.
Steve, you broke up when you were talking about the number of files. Were you talking about the number of chipsets supported?
Okay, yeah. The code base is large because there's a lot of chips to be supported, basically. each one of it's going to have, one or two files that are related to being the device driver portion. And also, not unexpectedly, the actual APIs for providing the system neutral platform for all this driver is large. So we end up with a lot of files when you're done. And the code itself is large. And it's written in combination of C, C++, and assembler. The C++ is mostly for platform-dependent utilities. C and C++ is pretty much where the drivers. And I'd say the drivers are 80% C with about 20% assembler thrown in for performance where it's needed. Now, one thing I will say about this thing was actually supposed to be multiple CPU chipsets, but in reality, from what I've seen, I don't think they ever did anything except for the Intel chipset. I saw some code in the code base that supposedly does MIPS and things like that, and that would be fine, except for I don't think they ever did the assembler portion for that. Now, as you might know, the SciTech is also responsible for a lot of the work on the Open Watcom. And in certain areas, you'll find that the source code shares similarities because the same people are working on it, so it's organized similarly. But in reality, most of the development was done separately. What we're seeing is changes that were made once Open Watcom came into the picture. And we'll talk a little bit more about the tool chain later. Did that all come through?
Yes.
Any question?
No.
Okay. There's two major, if you want to break it up, there's two major functions. There's what we call the binary portable DLLs. If any of you have ever looked at your Snap installs and found a huge file called graphics PPD, that's basically the library. And it contains all the portable application code, or all the portable driver code. And then there's the platform-specific stuff. Oh, and also the graphics stuff, PPD, as you notice, is huge. Fortunately, because it's a library, any given implementation is only going to load a very small portion of it. So the way Snaps work in terms of drivers is very efficient. It's much more efficient than, let's say, Unity, which has a huge driver, which most of us don't even use 90% of the code that's in it, because it's for other chipsets than what we have. Then there's the platforms, what I call the platform-specific binaries. These are the things that start with SDB and Snap, and they do two things. They implement the OS compatibility layer, and they implement the loader. And once you have that, these things are, I call them thin layers, because they really do the minimum amount that they have to allow the portable code to run on the platform. One way of looking at this is it's somewhat similar to Odin, in that Odin provides this compatibility layer that allows us to run Windows stuff. And it's a wrapper. And that's what the platform-specific portions are. Now I'm talking here about what we see at runtime. The organization for the source is a lot different, although the output is these items. Any questions?
No.
Okay. A little bit about the build environment for those that are going to be developers. It's very structured and relatively complex. This is almost like a side effect of the fact that it is multi-platform. The main tool is eMake. My guess is that they didn't use WMake from Open Watcom because basically it came along too late in the game. How should I say? The SciTech existed long before Open Watcom was under control of, under control of SciTech. Additionally, now that's not, doesn't mean they didn't use Open Watcom. They actually used all versions of Watcom at one time or another to build portions of the code. But for one reason, they did not feel that WMake was capable enough. And so they chose DMake. And part of that, too, is that DMake was one of the first cross-platform make tools. And that was a requirement for them. Now they could use WMake, but it's a big bump to switch into. And in terms of functionality, DMake, while it's not as capable as, shall we say, the Linux makes, it's capable enough that they can write, the make files are fairly clean. The other thing is, you notice, it uses a lot of tools. And I think a lot of this has to do with the history. In other words, they picked the best compiler tool chain for what they were doing for a given piece of code, rather than forcing everything to use, shall we say, Open Watcom. Makes things a little more complex, but most of this complexity is hidden from you. You don't have to worry about it. You just have to make sure that your Visual H308 and Visual 365 are installed, and they work. Any questions?
No?
Sure, actually, OS2DDK. Is this
right?
Is this the latest one that we, as developers, kind of have, or did they have a better one than we have?
No, they didn't have. SciTech had access to some stuff that's a little hard to get, but not quite that much. For instance, even though they were doing drivers for IBM and doing the grad stuff, they never got access to a lot of that source, from what I understand. IBM said, here's the binaries, here's the docs, use it. That's the way they are. And it's sort of unfortunate, would have been nice. But we'll see once we actually, there may be things around there that we don't know of yet. Because at the point in time when we got involved, or even, I should say, I got involved with Snap the first time, when Mensis was getting involved with it, they were licensing it from Alt Richmond, and SciTech was gone for years. And the folks that were primary development, now, some of those folks are going to come help us once we actually get once we get things in place where we actually can start modifying the code again. But Mensis never had that, so it may turn out that some things are available. But I'm sure most of you have heard the name of Colin Kosick and Steve Wendt. They both work for SciTech, and they both offered to help where they have time. And they all have day jobs, so it's hard to know exactly how much time they're going to be able to give us, but we'll find out. And the reality is that's the parts that we don't have sources for really are not that much of an issue. There was technically nothing wrong with the DDK, other than the fact that we don't have the source for the latest binary drivers IBM has released. However, we didn't let that stop us, and the drivers that Arca Noae does incorporate all those fixes plus a lot more. In other words, if someone takes IBM's last binary drivers were 1.62 basically, and the DDK that's available to us, I think, is 1.10, and the stuff that David's been doing and the other driver developers has basically taken this well beyond the 162 level. And it's almost, you could sort of say at this point in time, having if there was a copy of a 1.62 DDK, we wouldn't find it very useful. We might learn a little bit, but we sort of already know because of the bugs we fixed. Any other questions?
No.
Okay, where are we now?
Current status.
Pardon?
Current status.
Yes, sorry, yes, slide 7. Okay, I am plugging along on getting the Subversion repository ready for use. But the big problem is that it's not all source code, which means if I don't check things in right, no one else will be able to check it out. This wasn't a problem in Mensis because basically I did the initial builds back there and got it to the point where I knew I could build drivers and also I could build the distributions. But that was hardly complete because I only checked in what I needed to check into the repository so I could keep track of any local changes. The rest of it was just all marked read-only, and I figured I'd check it in as I go. And we never found anybody else to hand the work off to, which was the plan all along. Because I was busy doing a lot of other things, so the idea was to get it ready and then pass it on to other developers and give them something where the learning curve would be a little less. But that didn't happen for a number of reasons. But this time, since we have developers in place, I really need to make sure that the repository is clean, and also that if it does have too much stuff, that it'll just be a distraction. We're licensed for just the OS2 and DOS portions. Turns out that what we were given is a lot more. And it's just cumbersome to have all that other stuff in there that's really not relevant to us, excuse me. So I'm in the process of cleaning that out. Also, deciding what's binary and what's not binary is more cumbersome than it should be because of the naming. It's easy when it's an exe file, but when it's a makefile.xxx and you're looking by extension, you got to make sure that XXX is always text. But anyhow, that's almost done. I had some personal issues going on back here that put a kibosh on anything resembling being productive around here for the last 4 months. And some of you know about it, others of you don't. But anyhow, hopefully I am past that. And my life will sort of return to normal and this stuff will start making good progress. And the other thing is, developers, you'll probably be wondering about global workspace for the SVN checkout. We're planning on, at this time, we're planning on going with AVN rather than something like Git, because I think it'll actually help the workspaces. Now, even with SVN, you basically can figure on needing at least twice as much space as you need for the source, because that's the way SVN works. But this is so it should do it there. And this only is the SVN. You'll also have, I'm assuming the developers already have their tool chains in place, so that space is already this space for other compilers, tools, and all that sort of stuff.
He stopped. Yeah.
On off connection. Yeah.
You may not have realized he's off yet.
Hello there. Let everybody back. Sorry about that. For some reason, unbeknownst to me, the tab decided it needed a reboot. Not to go complain to the tablet owner and tell her she needs to do some tech support. It passed back to me, but oh well. Okay, let's see, where were we? We were talking about current status. So, let's see, where did I drop out? Right when I was talking about disk space needs?
Right.
Okay.
Yeah. So, your code base, if it's an SVN workspace, is going to probably be about a gig. And whatever you need for your compiler tool chain and stuff, and things like that. However, I assume those are already be installed, so I don't really count them. Any questions?
Nope.
No?
Okay, next slide. Okay, what's coming down the way? Hopefully this will all be sooner rather than later, but life is what it is. I'm planning on doing some how-to guides for developers, which is basically, okay, here you've checked out this source, how do you start compiling with it? And basically where to go look for things. Because with this many files, it's pretty well organized, but you'd like to be able to ignore pretty much all the stuff that you actually don't need to deal with. One of the known issues with the current Snap distributions is they appear to have SMP issues. And this makes some sense because at the point in time when it was defined, SMP systems were few and far between, and IBM did not consider them end-user systems and so on and so forth. And the SMP issues mostly resolved to problems with the MTR and PATs, which are registers that control memory access. And David's already done the fixes for Panorama in these areas, so we expect to be able to port them without too much trouble to Snap, which means that Snap will simply run a lot better on SMP systems. Same is true for Visa. For one reason or another, SciTech never really tried to optimize Visa performance. And this makes some sense because their business was doing accelerated drivers. And the Visa was there basically if you happen to be running a chipset that they didn't support. And Snap in its heyday pretty much supported all of the widely available common chipsets. The only one I can think of that they really never supported that was common at the time was the ELSA Winner. Now that wasn't a big issue for ELSA Winner because ELSA did their own drivers and they were there and they worked. I will say they don't work so well anymore, but that's a different story. I happen to have a friend who insists on using one of those cards, and it just does not work well. Panorama can't handle it, Snap can't handle it, and he's having trouble getting the ELSA drivers to install on ECS 2.1. I keep trying to convince him to just get a new card, but excuse me one sec. But unfortunately, he's an eccentric OS2 user, so he doesn't want to get a new card. So we'll see what comes of all of this. Some of you know that there's a whole bunch of weird new connectors for video devices, one of them being HDMI. We're going to make sure that support works correctly. Plus, the other ones that come along. This will require, we'll have to educate ourselves on what it actually takes to enable these connectors and so on and so forth. How much work it'll be, hard to say yet. We really haven't looked at it closely. Now, some folks, I think, the HDMI just works, but I think a lot of it has to do with the Visa bias in Panorama. It's not so much in Snap. But we're going to learn more as we go. Another thing we want to do is make sure that dual monitors are supported where we can. And since most of the chipsets that accelerated drivers existed for are really no longer available. We're going to see what we can do to refresh the set of accelerated drivers we support. And that way, you know, we will not be using RAD. We'll get a little better, we'll get somewhat better performance. Now, the interesting thing about, excuse me, not RAD, I'm sorry, I mean VESA BIOS. The interesting thing about VESA BIOS is that with computers being so fast these days, it's hard to tell the difference between accelerated video and VESA video, especially for us, where we're just doing 2D stuff. But we'll see. You know, this is where we're going. Okay, any more questions?
Yes, Steven, there is a question from the chat room.
I'm having a little trouble here.
Yeah, there is a question from the chat room. It says, is it possible to implement vertical flip of the picture? This feature will be useful for ThinkPad tablet laptops. The vertical flip, when you move the laptop upside down, and it flips the image.
I'm sorry, you're breaking up a little bit. Must be the microphone.
Vertical flip, you know, for the like the pads, or you know, like the pads have, or like the small. Yeah, can you hear me? Can you hear me here?
Yeah, that's a little better. Yeah. Now, vertical split. Hard to know if that is. Again, if we have the specs where the monitor tells us when it's flipping, then the potential is yes, we can do that. Actually, that's really not so much a driver thing as an application thing. Now, there can be support in the driver for doing it, but what you're really doing is you're changing. If you think about what happens with a vertical flip, you are changing your logical resolution. Now, let's say you are, HD resolution. Let's say you're 1440 by 1200. You flip it, all of a sudden you're 1200 by 1440, and the window has to change, or otherwise everything gets squashed. But that's a possibility. What do you think? A lot of what's going to determine which drivers get accelerated support, or which ones we get requests for, and additionally which ones we actually have available hardware data sheets and such available, so we can actually write the code. But there's no reason that can't happen. Another thing I would like to see is, which is a personal thing, I'd like to be able to switch between internal and external monitors on more of the laptops that we use a lot. It used to be this just plain worked, like on the earlier ThinkPads, like things like the old ones, like the T42. But by the time the laptops like the T60 came along, IBM was not so interested in supporting it, so they didn't. And basically, you can only switch when you're booting up, and then after that, you're stuck either it's internal or external. Now, obviously, it doesn't work this way on other platforms, so the hardware is definitely there to support this. But without the hardware data sheets and such, it's a little hard for us to do it. So these are things, we want to do in certain cases. Other things we know we can do, like the first 4 or 5 items on that list, we know we can do. And the dual monitor support, probably. Some of the other things, they become a resource issue, where not so much developer resources, but actually information resources. Because those of you that use Linux have probably noticed that the source code for a lot of the video drivers is simply not in Linux, even though it's quote-unquote open source. The vendors have basically twisted the Linux owner's arm and said, here, we'll give you a binary, and you can use it if you want, otherwise tough luck. So they've been able to keep a lot of their information closed. Now, they do have, it may be possible we can get access to some of this information under an NDA. Hard to know. We're just going to just work at it and see what happens. Anything else? Lots of time for questions.
Snap questions? Anyone?
Well, yeah, I don't know snap. HDMI? You mentioned HDMI support, and I guess it's not even really a snap question. It's, does it work on Panorama? Is that hard to do, the HDMI connector?
When you start talking about Panorama, you're limited to what's supported by the VISA BIOS, because the driver really is not doing a heck of a lot except making BIOS calls. So, if the VISA BIOS has the facility to tell you that it has an HDMI connector, and there's a spec for how to switch to the connector, then you can use it. Now, what I've been told, though that I don't have any HDMI stuff here, is that sometimes you plug it in and it just works. And again, that's the BIOS implementation, because the BIOS knows, the guy who wrote the BIOS knows how that chipset works, okay? He knows how to check if the connector's connected and so on and so forth, and do the switches. I don't recall anything in the VISA API that exposes that. David might know better. He's looked at that code a lot more than me. David?
Yeah, I'm here, but we can talk about that during my presentation if you want.
Okay.
It's an ongoing question.
Yeah.
All right.
Well, in answer to that question, no, there was nothing exposed in the API regarding switching connectors.
Pardon?
There is nothing exposed in the API regarding connectors and switching between them.
Yeah, that was my understanding too.
Steve, when we talk about dual monitor support, are we just limited to 2 monitors? What's the upward limit?
What's the what? I'm sorry, you're dropping out a little bit.
What's the upward limit for multi-monitors?
For what?
Multi-monitors. How many heads can we effectively run?
I would guess 4 heads, but I can't. I think that's actually a chipset limitation. It's a function of how much memory you have, because really, dual head stuff or multi-head is 2 things. First of all, obviously, it's the number of connectors you got. And second of all, it's the amount of memory you got in terms of how it actually works. If you look at dual head stuff, which is sort of clumsy in some ways, for example, it really just gives us a big logical screen and says, okay, let's say in the dual head system, the left screen goes out on the left monitor, the right side of the screen goes out on the right monitor. Now, there's some stuff that needs to be done there so that your dialog boxes that the application programmer may come up centered go out on one monitor as opposed to the other. And I think, and there's some gains and techniques that are used in the Snap drivers to make sure that happens. They actually do that translation, because there's really no support for dual monitors in the presentation manager. So it really thinks there's only a single screen there. And you see some of the same type of issues we see in the ePager, where things don't always go exactly where you'd like them to. And it's because it's really not a hardware partitioning. The software does not think it's drawing 4 screens. It thinks it's drawing 1. And the split is logical. But I think probably 4 heads are reasonable. I don't know that, I haven't seen anybody advertising 8-head stuff. Now, sure, it exists for specialized stuff, but at the consumer level, I don't think I've seen anything more than 4-head. And we should be able to support that. I think that's doable.
What about multiple zoom levels?
Again, that should be doable, because especially with the accelerated, because that's mostly handled by the hardware. And Snap already has the hotkeys to be able to do the zooming and so on and so forth. Now, if you're talking about a particular chipset, then that becomes, do we have the information we need to implement that code?
Okay, related to that, one of the complaints about OS2 over the years has been that we can't change video resolutions without a reboot. Can you talk to that for a minute?
Yeah, it's a big deal. And there are lots of reasons that doing that is so resource intensive it'll probably never happen. Essentially, that resolution is set by the first instance of the PM shell. That puts the system into graphics mode. And there's no way to restart that code. And it wasn't designed to be restarted. Now, is it possible that we could come up with a way of allowing it to be restarted? Possible. But it would be an R&D effort. And what you're talking about is how do we take data that is basically designed for one-time initialization and make it and allow it to be reinitialized? I'm saying it would definitely be much more reasonable effort if we had access to source code. But anything we do would have to be reverse engineered in the binary mode, patches, or maybe, just maybe, some sort of a shim that we stick in there between the kernel and the first instance of PM shell. But it would be a big, which is something I've thought about, but it's a big research effort to go find out, okay, what can we do to, after we kill this first instance of PM shell, what else do we have to kill so that when PM shell comes back up, it reinitializes properly?
Could you virtualize that instead so that the PM shell doesn't know that it's changed? So you put a virtual driver in between. The PM shell thinks it hadn't changed, but we're changing the aspect.
But again, you are not going to implement virtualization with patching. All doable with source code.
Well,
okay?
I was thinking about in terms of a driver. You know, basically have a driver in there.
This is not a driver issue.
Okay.
This is PM is ring 3 code. It's effectively, if we think of it as part of the kernel, right? And it is because, you know, we can't run our desktops without it. But PM shell is ring 3 code. Take a look at it on your system.
Well,
it's just another application, but it's one that it digs itself deeply into the way the kernel works and the way drivers work. And it's the same thing. For instance, I'll give you an example. The device driver API has the ability to unload drivers. However, and you've seen this on Linux, where you can insert a module and unload it if you don't need it for some reason. Or even if you're testing and the kernel knows how to unload it. That's not fully implemented. The API is there, you call it, your system will crash. IBM initially planned on being able to do that. They were thinking ahead, but they never had the business need to actually make all that stuff work. And I'm sure the same thing with on-the-fly resolution changes is there too. If we actually looked at the source code, we would see that there's some hooks in there for doing that. But that's a very big difference than having something in place that could be patched to make it work.
Okay.
On the forum, they're talking about that. They're saying that there's a legend of a Trident driver that can do the resolution changes.
A legendary Trident driver.
Yeah. And they're asking about hot plugging a monitor in, but once you hot plug a monitor in, the best you can do is clone, isn't it?
I've never heard of that Trident driver, nor have I seen it run. I do know that there was a specialized Trident driver that was used for some vision systems. But, and when you say resolution change, you may be able to change the resolution, but then the application has to be told that the resolution changed. Now, I could believe that if I had a specialized driver, that I could make a DOS-IO control call to change resolution on it, and all I was running was my application, I could make it work. But what we're talking about here, when you ask a general question about how do I support resolution on the fly, resolution changes on the fly, that is a very, very different thing. Does anybody have access to this Trident driver and the card? Or is it just like a rumored thing?
I think it's a rumor thing. It's a legend that's been around for some time.
Yeah, I don't know of anyone who actually has had or has seen the card or the driver. Just people who say that they've known people who have said that they've been in touch with the card or the driver.
Yeah, my cousins, brothers.
I have a friend of a friend who has one.
I have a friend of a friend who read it on the chat.
Right. And in a certain sense, changing resolution is not that much different than zooming. Now, this thing may have had a zoom function rather than a resolution change function. And then the application had the smarts to sort of notice that the zoom factor had changed and adjust things to match. Because even now, there's magnify applications out there that will give you a little window that magnifies a block of your screen. So it's not that it can't be done. It's that doing it system-wide and in a generic fashion doesn't exist and is unlikely to be able to be implemented with anything resembling the resources we have available. Now, if anybody has a great idea how to do it, yeah, we'll look at it.
One last thing for me that came up when we were talking about HDMI connector support is Mikhail and I had a discussion about supporting HDMI, and he reminded me about the fact that HDMI also carries audio and how we would have to work around either not carrying audio or carrying audio over HDMI. Can you talk about that a little bit?
I don't know the internals of it, but my guess is the audio and the video portions are separately controllable. There's probably, in the hardware, there's probably enabled for audio output and video output that can be separately controlled. What they actually are, I don't know. But I can't imagine that it would have been designed without registered bits to control each one separately.
Do you anticipate that we would be able to handle audio out through HDMI in Snap?
Well, we should be able to handle video out. Audio out is totally different. We're not really going to do audio with Snap. What we will want to do is make sure we don't stomp on it if UniAud ever gets to the point where it can control HDMI. Now, I'm guessing the ALSA code already has that type of support in it, and we simply don't know it because our UniAud builds are sort of in need of a refresh.
Okay. So essentially, Snap is just involved in handling the video out over HDMI and making sure that it doesn't overstep the whatever connectors are required in the HDMI interface where audio might be.
That's probably a reasonable statement, although we've got to keep in mind that there is an audio Snap. Not production quality or anything like that. I have no idea of how close it, how much testing they ever did, except for maybe 1 or 2 test case drivers to make sure the API is removed. But logically and intuitively, since we know that audio goes out on HDMI on some systems, there may be support for it in there. Might be worthwhile to do a scan of the APIs and see if any of them have HDMI in their names.
But I had to take a point on that. I brought up a system, a AV system at my house, and I have a Sony power amplifier which has HDMI inputs, and I have many devices, Blu-ray and things like that, which have HDMI outputs. So some of them, the Sony box knows it's getting the audio from the device, and some of them I actually have to play the audio through the device. So a typical case would be, I've got a notebook computer, I want to play a streaming video through the AV system, and so it would be very nice to be able to have the audio go with the video into the system rather than having the abandoning the 5.1 audio system, which the power amplifier is able to control, and playing the audio through my teeny little speakers on my ThinkPad.
Yeah, that's all handy stuff. You know, it's how much work, how close we are to being able to do any of that. Hard to know until we actually look at the hardware specs. See, one of the advantages all these guys that do this have is they go out and they spend, a couple $100,000, $300,000 to license the IP from the vendor. And they have these things called data sheets and specs and reference designs that they get to work from. We don't quite have all those advantages.
Yeah.
Okay, use your Warpstock link on Amazon.
You know, consider us stone knives and bearskins relative to some of what they have available. And again, it's the same thing. To go back to what I mentioned about Linux, you know, I can guarantee you the Linux guys don't know how a lot of this is done on some of the video drivers they have available, and perhaps the audio too. All they know is they've got a binary blob that has an API that they can talk to control this stuff. Now, one of the things that we've thought about, and other people have thought about, is being able to run those blobs under OS2. But it's not an in-process project yet.
Steven, there is a question on the chat room about if you have seen any kind of 3D support for 3D chipsets.
3D is extremely unlikely. You know, Snap has MGL support, but it's old. And updating it, there has to be a real need for it, i.e. multiple end users or multiple customers. And the other thing is too, you know, anything 3D that was there, well, yes, it could get chips that have help from Snap in terms of acceleration and stuff like that, but it would always be application level, not kernel level support. That might have to do with Stone.
Any other questions for Steve about Snap? I think that pretty much covers it, Steve.
Okay. Hey. So you guys can either go get coffee and tea, or find more questions.
Okay.
We're good. Thank you.
Thank you very much. You want to hang out there, Steve? We can move the monitor and the computer anywhere.
I'm in my cave for the day. You know, I'll give you the 360 view.
Okay.
Wow, cave. Blurry.
I got stuff to do until I have to turn into an Uber driver for Joan.
Yeah.
Yeah.
You mentioned earlier about the zoom. That was kind of my idea on the virtualization. You have, as far as you tell your PM shell, it's one size, and everything else basically just zooms. You know, so it can flip on the switch on the fly.
Well, that's really the same as fixed resolution to me. In other words, first of all, when you say shell, which shell do you mean? Do you mean the WPS, or you mean the first instance of PM shell?
First instance that you can't restart.
Right. No, there's nothing to say that multi-head effectively does that in a certain sense. Oh, yeah. Sure, you can lie about the actual physical resolution and do whatever it takes, but you're still going to be limited to the number of pixels. And someone's got to interpolate them to bring them down. Some of that's possible in a certain sense, but one of the big problems is changing that logical resolution after you're up and running. Let's say you do this zoom thing and you say, well, I have a 10,000 by 10,000 screen. And I want it broken up into, well, actually, you don't know what you want it broken up into. That's where it gets interesting with dual head. Because remember with dual head, as I mentioned, our dual head is not really separate screens. It's one big screen broken up into logical screens. And when we lay out our windows, we lay them out the way we want. It's not like ePager where it's going to, when it draws certain windows, because it's in the WPS, it knows, well, gee, these objects need to be propagated to every window. Unfortunately, the device driver is never going to do that. But there may be something we can come up with that will sort of emulate it a little bit better than we can do now. But it'll never be changing resolution on the fly. What it may be is zooming. But zooming is not quite the same as changing resolution because, again, zooming always implies interpolation when you want to fit it in a small window. Changing resolution really means that you draw more or less pixels. And everybody knows how many pixels there are on the screen. It's not that things can't be resized. Let's say we were running in a virtual environment, like VirtualBox or whatever, we can resize those windows all we want. And the screen resizes to fit. The contents of the windows resize to fit. But that's expensive computationally, and additionally, it's done by the application, VirtualBox in this case. There's no real hardware support for that. So there's the compute cost. Now, do we care? We don't care that much only because our operating system was essentially designed to run on 486s, and we're now running it on core duos, and so on and so forth. So we've got so much more compute power. The fact that the code is inefficient is really gets to be a little irrelevant. Gets to be a bit irrelevant. Now, yes, if we were trying to build 3D games and all that sort of stuff, then things would bog down. We'd find out that things wouldn't run as fast as they might on other platforms. Because they do have accelerated 3D and so on and so forth.
Was the topic still floating around about 3D support on OS2?
No.
Oh, sorry.
But as long as you bring it up.
Well, it has been around for 10 years, but the other problem also is that what other applications are there that you need to reverse up the track and first ask the question, what applications do you want to port before you need to make a case for it. That's the same thing with the webcam discussion. It's nice that you've got the tools from the rule, but we're 2 years down the track, and it's not a criticism, but I've always said when people ask me the question about USB webcam support, well, what application do you want to use it with? Thomas Klein once made the nice comparison, it's nice to have your own personal digital mirror on your computer screen to look at yourself, but yeah, you want to hook it up, so maybe it's a pity that Mercury Messenger died off the Java program, because that's at least had a Java plugin. But just as with 3D gaming, we can get a 3D, let's say we do get a 3D API support on those two. What applications are there to actually port it to? So okay, yeah, we can put a checkbox, we've got 3D support, but I've never really seen anybody mention which games or applications you could port OS to that would be useful, or that somebody say, yeah, that's something I really want, that would make the platform worthwhile. So if somebody can answer that question, I would really be thrilled to hear it.
So speaking of restarting PM Shell, if anybody wants to experiment, you can actually try it on your system and see what will happen. One of the things you can do is you set the code shell to other than PM Shell, set it to command.exe, then you can just start PM Shell from that command line section. When you boot up, you'll get a full screen section that was basically very similar to how the system would be before PM Shell started. Then you can start PM Shell, it'll start in WPS, then you can bring up your favorite process killers and kill those two shells and watch what happens.
I tried that already once because I was curious. I created actually on this discussion also keeps popping up, that if you go to the Snap repository that I referred to so many times, there's a ticket there at NetLabs that talks about restarting the PM Shell, and actually tried it. Only start the first instance of PM Shell, and once it comes up, you can't kill it anymore. So I already tried it with setting the prod shell to CMDX, but you can't kill it after the first instance came up.
Right.
So
yeah, that's the current state, but with enough experimentation, we may figure out how to kill it.
Well, all this discussion.
But it's an RPG project to go figure it out.
Well, but even if you can do that, then the question really becomes, let's just say that you can restart the PM Shell to load at a different resolution. What will happen to the current running applications that are using those instances of PM Shell to display their graphical information? You would be, because those DLLs are also in memory and use. So I think we'll be opening up a whole can of worms that I really wonder if it's worthwhile to get this. I think the feature sounds nice, but apart from killing the prod shell, if somebody wants to read the ticket and comment there on it, on the Snap track, Achim Hasenmüller from Innotech wrote about 13 years ago on an IRC chat that I say that, quote, with some tinkering you can kill PM Shell, and he had seen other people do it. The trouble is he didn't tell people how to kill it. So.
Well, I have the same question about this. I mean, this is all regarding changing the screen resolution after you boot it, right? Well, I have the same question. Why don't I ask the same question you did about the 3D stuff? Why do you want to do it? For what purpose?
Switch between internal and external laptop, going from the external monitor versus the internal.
Well, you can't do that anyway without rebooting. So
yeah, not at this point.
So why do you want to do that? Why do you want to change the screen resolution after you boot it?
Well, if you plug in a second monitor, I sit there, I take my laptop, I've got it in the dock, I pick it up, I go into another room, I go somewhere, I don't have that secondary monitor. Or I'm in another room, I've got it booted up, then I come in and I hook it into the dock where I've got the secondary monitor, and I can't switch whether or not.
Okay, you're talking about a really rare.
It's not rare. When you go and plug into a projector, the projector does not have the same resolution of your computer. So you switch in other operating systems.
Why are you doing that after you boot it? Don't you plug in the projector and then boot?
It is more because other operating system has the facility.
Same thing with the 3D. Ask the same question. Why do you need to do this? Why is it such an important thing?
Well, I think it's more important, the resolution change, than the 3D, because it's more useful, or it's more used to have a projector, or to plug a projector from time to time that requires a different resolution. And other operating systems allow you to plug it without rebooting. It's something very useful to not reboot every time you plug that projector.
Well, here's one, for instance. You have this here. Now you unplug this thing. Now the only way I can shut that thing off is by knowing how to shut it off, or I power it off, because I can't see.
That's different. That's a different.
But no, it is and it's not. I mean,
that is not a screen resolution issue.
But I'm saying at that point, though, I mean, it's the same. To switch it over here, if I'm not plugged in, when I plug,
that is not a screen resolution issue.
So if I'm not plugged in, when
screen resolution.
It's an ACPI issue that
no.
Well, the BIOS does it correctly. Yeah. You don't have the option to switch the screen.
I'm asking about screen resolution changing after boot.
We're not talking about output port.
We're not talking about output ports.
Yeah.
I actually have some real-world examples from other platforms, and the only reason that I've seen it done on other platforms is for compatibility with older applications. What's happened is if you're running an older application that wasn't designed for higher resolution, a lot of times the windows won't draw right. Yep. Now, the platforms that allow you to change resolution on the fly, what they do is when they run that application, they change their resolution for the duration of running that application so that the windows draw. Then they switch back and they've got their nice wide screen or so on and so forth, whatever it is. But that's, for me, that's really the only case where the change is needed. Now, if you had a case where you could have dual outputs, both to an external connector and to your laptop screen at the same time, then changing resolution on the fly would be handy, because typically the resolution of your external is different than the resolution of your laptop. And so for those cases, if your boot time is fast enough, it becomes less of an issue, because you can plug in external, leave it in for a while, and sure, it's not perfect, but the time it actually costs you is really minimal.
And especially since Panorama has the ability to automatically configure itself to whatever is plugged in at boot time. So there's no reboot involved at all.
But
that's true.
But still, it would be nice. I understand that it would be nice if
you could
have your top screen change resolution to match the external monitor resolution, so that you could look at both. Like I say, on my T60, when I do presentations, I have to look at the external screen, which can be cumbersome at times, depending on what you're doing. It would be nicer if I could look at the laptop screen while doing the presentation and just know that the same image is on the external screen. But it's not built to implement. And again, it's one of these things where it's an inconvenience more than a showstopper. Now, Lewis doesn't have that problem because his T42 switches nicely.
T43, I don't have the heat problems. But yeah, I can swap back and forth between the projector and the internal display and both of them with no problem on this machine.
Yeah, can that be implemented in the newer machines? Got the one thing?
It can be implemented, but this machine does it in BIOS. If it's not implemented in BIOS, it's got to be done some other way.
Well, what I'm saying is this T60, could there be a program written that would allow you to do this toggle back and forth thing?
I assume it's probably possible if the hardware doesn't turn.
Right, that's what I mentioned earlier. The T42, I have a T42 and a T60, and the T60, as Lewis says, switches nicely. Now there's limitations. The T60 is a 1024 by 768, so if you're a presentation, you are not going to get any larger presentation screen than that. You're not going to get any HD or anything like that out of it. Now the T60 is widescreen, so obviously it's going to give you a nice widescreen image on your external display if it exists, if your projector is capable of it. But you can't switch back and forth because the functionality is simply not there in the BIOS or the hardware. I'm not quite sure how those buttons are implemented, whether they actually go into the 32-bit BIOS or whether they're actually just hardware connected. Just to have hardware functionality. Yeah. Because remember, at the time when you do that switch, Lewis, you're running in protect mode. So when you hit your function F7, that's probably going into the SMI BIOS, I think. But I'm not sure. But I know the driver doesn't know what's happening.
Right. The driver's blissfully ignorant. It will swap whatever the resolution is on the desktop. That's the resolution that's going to come out the other port.
Yeah, but that usually works out fine on the prior machines I've had.
Well, depending upon the desktop resolution, and let's say you're going to a projector, right? This projector is pretty good about adapting itself to different input resolutions. But I normally run my T43 at 1400 by 1050. On our old projector that Warpstock had, I couldn't drive the input at 1400 by 1050. So when I would switch, I got a black screen because it wouldn't set the input. So I had to switch back so I could see my desktop, change my resolution to 1024 by 768 or 1280 by 1024, reboot, and then I could switch back and forth.
Yeah.
So that's the whole thing. We don't do multiple resolutions on. We don't do different resolutions on different monitors.
Yeah.
And the switch to internal to external has to be is either implemented in the BIOS machine, or we're not able to do that right now. Now you ask if it's possible that we would be able to do it at some point. It's possible.
Yeah. I've been teaching with machines like this, not like this one, but the one before, where I can switch back and forth. I can always have my presentation in front of me and the screen behind me. And this T60 makes that
impossible.
Yeah, impossible. And sort of difficult.
It's on my personal HMS.
You are, by the way, aware of it depends on the laptop, but the main reason that it's not possible when eComstation is booted to use the FN F7 button is because ACPI gets loaded, and then, from what I understand, the BIOS basically says, okay, ACPI is loaded, it's no longer BIOS functionality, and in order to have that button function, something needs to be implemented. However, what you can do on the T60 is before you boot eComstation, and you're in the boot manager or in air boot, and you then press FN F7, then you can at least switch over to the external screen.
Well, if I have both of them plugged in, if I have the projector plugged in already, it'll feed both of them?
Yes. But you need to perform the switch pressing FN F7 before eComstation or OS2 starts.
Robert, Stu's question is, will it auto-detect that there's an external monitor also by itself?
All BIOS functionality.
So all BIOS functionality.
All BIOS functionality.
So if I have the projector already plugged in, it'll feed the 10,000 BIOS.
If BIOS setup says your only display is the laptop display, then even if you have an external monitor connected, it won't light up.
That's settable in the BIOS.
In the system BIOS. Yes.
Okay.
It's an option.
In the system BIOS, it's a setup.
You go into the BIOS.
Yeah. And tell it whether you want both by default, whether you want one by default, whether one is primary.
And it's also in the T60 BIOS.
It's in the T60 BIOS also.
Okay, so if I just have it set to do both.
Let's say you have it set for only the internal. Then what you do, yeah. If it's set only for internal, then you can press the keypad combination, to override that before the system moves into the operating system, before ACPI moves.
Okay.
Let's say you have your BIOS set for the laptop screen on LCD only. And all of a sudden today, one day out of 365, you want to drive the projector. Okay. And you've got the projector plugged in, and you don't go into the BIOS and change the setting.
Yeah.
You should be able to press function F7 before the system boots into OS2 and get the other display working.
So that would be, say, before the block.
Correct. Long before the block. Long before the block.
That would be your last chance to even get to the block?
Yeah, exactly. When the IBM logo comes up, press it then.
Okay.
That's fine, with the IBM logo, not the OS2 IBM logo, the IBM ThinkPad.
Right. You can do that switch anytime you're in full screen text mode, basically with air boots displaying,
right,
or boot managers displaying. Essentially, the BIOS, you're in text mode, you're in full screen text mode, so you can do that switch.
Or like when it's running through all the stuff that's loaded?
That's too late.
That's too late?
It's too late, because it's going to load ACPI very early on.
Okay.
And that will be too late. Now, if you set your BIOS the way David has his, so it's set to drive both of them all the time, whether it's connected or not, it doesn't care.
Yeah, it'll just...
Some BIOS do care.
Really?
Yeah. Some do.
So if you have it set for both, and you don't have one connected, you complain?
Yeah, well, it's won't enable. If nothing's plugged into the external port, it's never...
Then you get a black screen on the internal also.
It never drives this.
That's on what machine?
On some machines.
Some machines, it depends which BIOS you got and how
But that's how it works, that's how it's designed, so you need to figure it out per machine.
Of course.
Hi, Louis.
Hi, Joe.
So I'll admit that I came in late to this, and I'm probably going to get laughed out of the room for the question, but with the advance in display technology, what are the chances that we're going to ever see high DPI support in eComstation?
Pretty good, actually.
Really?
Yeah, I think so. As we add chips to Snap, you'll see the high DPI support added with the support from the chipsets that do high DPI. One of the first chips on the list is the Intel HD series, and that should get us some pretty decent resolutions.
Which will be output on what devices? Talking about external displays or
any displays that will support them. So if you have, let's say we're able to add the Intel HD chipset to Snap.
we're talking about a big external.
And let's say that your Intel HD video chip does 1900 by 1600. Then 1900 by 1600 on your external monitor, if it supports it, should not be a problem.
WordStar will look great on that.
Well,
WordStar would be fabulous.
yeah, like
I understand that, but I got distracted. With the W550 because it has a 3K screen.
He's not developing it, so.
It's 2880 by 1600 and 15 inches. That's a lot of pixel density. Although you can drive a display like that, having the interface to be able to use it in any meaningfully usable way, not having it 200 from your screen. How is that going to be?
What's the video chipset?
This W550 is Intel HD.
It is an Intel HD.
The W550 has NVIDIA Optimus, and that's not supported that well by anything. So I don't know what by.
NVIDIA is a bit of a pain in the neck with their specs, which makes it difficult to.
They must be really proud of them.
I kind of regret not going to
It's a tough chipset. Assuming we get the support for the Intel HD, and as I say, that's on the roadmap, then we should be able to handle any of those DPIs that would be, any of those geometries that are supported by that chipset.
I think what he's asking though, so like, you know, when you go into the snap, it's got the things that says like you can choose the 90 or the 120 DPI thing. I think he's talking about the fact that if you start getting all those pixels in the high resolution, you start getting really tiny, you know, if you don't have something to increase that.
We need to.
I think the actual panel was like 240 dpi like that.
Yeah.
Well, remember that Snap
has the ability to do that, because remember I said it's got the 90.
You can add monitors to Snap.
Yeah.
So, I mean, if you have a monitor, you know, let's say that we don't recognize your monitor because it's newer than what's in the Snap package. You should be able to add a monitor configuration file that says that that monitor is capable of doing that. So we can tell the chipset to turn it on, but as a protection measure, in the monitor data as it's Snap, if it doesn't recognize your monitor, it may limit you to what it thinks, you know, like generic SVGA. But if you update the monitor definition, which is an end-user function in Snap, you should be able to get a definition for your monitor and the other driver. We have to look at that monitor edition stuff.
Yeah, one thing you're going to find is monitor farm is, thanks, Hank. You can say hi to Roger. Oh well. One thing you're going to find is, you know, the monitors list was designed mostly for analog monitors. Before they had, a lot of them had PVC and stuff like that. I think you're going to find that almost any monitor we plug in these days, we're going to detect the resolution that it's running at.
That's what I figured. Yeah. The digital ones all tell them.
Yeah. The thing to consider is, you know, we've pretty much got back to the world of fixed resolution monitors. You know, in the analog days, you know, we started off with everything was 60 hertz only, and it ran one size, and the chipsets basically ran on one side. Then we got to this bit where we could basically select our resolution for a while on the analog. But pretty much once we went to the flat screens and the LCD panels and so on and so forth, we're back to fixed screen monitors, fixed resolution monitors. And most of them don't do a really good job of the zooming and stuff like that. They assume that the OS is going to handle it. Like this one here that I've got, yeah, with auto sizes and all that sort of stuff, but I can't really force it to do any other resolution than what its native resolution is. And I think we're going to find that's the case with most monitors, but I don't really see detection as a problem. You know, I think we'll see how much we can do with the existing zoom functionality, because that's one of the things that we did lose when we went to mostly panorama. And that's a software thing. That zooming is all software. And our systems should be capable enough to handle it, so I'm not too worried about the actual compute time cost of doing it. And also that zoom factor was hotkey driven. So essentially, in some ways, you were getting a resolution change without getting a resolution change. It was more to make small fonts easier to read, or lower quarter of the screen easier to read, because nothing resized itself. You just decided, well, I'm only going to look at this portion of the screen. But I want to look at that, because some of that stuff, I don't think anybody's really used it in years. Because a lot of us have switched away from Snap, so we're not really totally aware of what its capabilities are. So we'll see. And once we start doing builds and we start experimenting some more, we'll know.
How long do you think it'll be before we do have something to look at?
I'm not going to put a time frame on it. You know, I mean, like I say, it would have been done months ago if there wasn't a broken neck in the house. Yes, right now, where I stand right now is I'm just about ready to do the initial commit, get the properties right, and do a baseline commit. And that'll give you something that, if you really wanted to work, you could probably build on. what I need to do then is backport my localization changes that just made it a little bit easier to run on multiple systems. The way that SciTech developed is they had build machines, which were basically a machine with a single partition that had exactly what they needed to do the builds, and they just imaged them. You know, it's not like what we're going to have, where everybody's going to have a slightly different machine. So we need to be a little more flexible. And of course, since my machine didn't match the build machine, you know, I implemented most of that flexibility. And also, there's other little things, but you know, it's just right now it's just time. There's no technical problems. I just have to find the time to work on it.
Best guess, Neil, is 2016. I mean, I know that that's like the broad side of the barn, but I mean, it's a near-term project for us.
Okay.
It's on the hot list, so 2016.
Yeah. You know, let's put it this way. I would be extremely surprised if we don't have usable builds coming out by the end of the year. Wow. Which we're talking, you know, actually, nah, I'd say, you know, 6 weeks, I say at worst. Given my current load level and stuff like that, I'd be really surprised if we don't have usable builds coming out by the end of, when I say usable builds, I mean a build that other developers can take and start looking at putting specific chipsets and things like that. Didn't get too much into detail about how the build process works. But essentially, there's two parts of it. There's building distributions, which make file, which does a little bit of compilation and a lot of assembly of pieces into zip file. Then there's actually building the drivers and getting them tested. Now, those of you who are going to be developers will find they have this whole thing called certification. And I don't know whose idea it was, whether it's something that IBM required or what. But essentially, when you do a distribution, you do not compile any drivers. Drivers are actually already compiled and the binaries are in the repository. And they've been marked as certified. Because some of you may have tried chipsets that weren't fully supported, and there's the GA mode option to tell it to run non-certified drivers. That's what that's all about. Essentially, unless you run with that option, even though the driver binaries may be in the BPD, graphics.BPD, they will not work because they aren't certified. So there's that process, and that process is essentially build yourself and load the little sucker in a shim to do your driver testing. You don't have to build the full graphics.BPD. Basically, build a little one that just contains your driver in it. But that's a process that I just had gotten started at when Mensis shut down the development I was doing. I tried to build a couple drivers, got them to build, because Jerry Rash had like the 945 that wasn't totally supported. We tried to put the support in there, and everything worked except the driver didn't work. The driver detection wasn't right, and that sort of stuff. But this is just, you know, testing stuff. One of the good benefits about testing Snap is you can test at the source level for most everything. You use a debugger known as SciCat, which is a source level kernel debugger. And you can test, and you can also run it over the network. Some of you might know that Mars is doing a certain amount of his driver testing via iCat and a network connection. And the benefit is it's a lot faster, and you're working at the source level rather than at the assembly language level. So it's a little more efficient. But that part of the system I have not really fully come up to speed yet on. I've got a ton of nodes, and I've got Mars's nodes, because I actually helped him get his stuff running, but I never needed to get it running here, so it's not fully documented. I just have to go by his nodes. But we'll get there.
Yeah, we're over time.
Just looking at the time, we finished the time slot for the morning and gone a little over. First session this afternoon, 2 o'clock.
Yes. Okay.
So you have a little under 2 hours to grab lunch or whatever else you want to do.
Thank you very much.
Thank you. Thank you, Steve.